Standard 2.4. Write a sine or cosine function from its graph using the amplitude, period, and vertical translations. All right, let's take a look at our first example here. When we are writing a sine or cosine equation, we want to essentially figure out several things. What's the value of our a variable? What's the value of our b variable? What's the value of our d variable? Is it sine or cosine? Is it positive or negative? There is a c variable. That's something that we don't talk about in this class. All right, so the first thing we want to do is figure out the values for a and d. Those are the easiest. And the best way to do that is to draw in your max lines and your min line, and then figure out where your center line is. Well, there's 4 units between the max and the min here, so the center would be 2 units away from either. So here's the center line. The value for D is the location of the center line. So the center line is at -3. D is equal to -3. A is the amplitude, the distance from the center to the max or the center to the min. So how far from the center to the max or the center to the min? That's 2 units. So our A value is 2. B is determined by the period. It's not the period, but the period helps us figure out what B is. There are a couple ways to find B. One is to count how many cycles you have from 0 to 2 pi. So if we start at 0 and go out to 2 pi, how many cycles do we have? In this case, we have half a cycle or half a rotation. So that's one way to identify that B is 1/2. A second way to find B is to use the formula B equals period. Let me take that back. B equals 2 pi divided by the period. And so we have 2 pi. How long is the period? Well, the period is the length of one rotation. So if we figured out how far from the beginning to the end of that rotation, from -2 pi to +2 pi, that's 4 pi. So the period is 4 pi, and if we simplify this, we get 1/2, same as we did earlier. Next thing we want to do is to figure out if it's sine or cosine. Notice the y-intercept here is at the max. When the y-intercept is at the max or the min, it's a cosine graph. When the y-intercept is at the center line, it's a sine graph. And finally, we have to decide if our function is positive or negative. Because we're starting at the max rather than the min, it's a positive cosine. If we were starting down here at the min, that would be negative cosine. And if we were starting here at the center, that would be sine. But we're starting at the top, so it's positive cosine. All right, so now let's write our function. The general form is y equals a cosine bx plus d. So in this particular case, a is 2, cosine b is 1/2 x plus d minus 3. And we said it's positive, so it's going to remain a positive 2. That's our function. Another way to write it is y equals 2 cosine, and instead of 1/2 x, we can write it as x over 2 minus 3. You'll often see it that way as well. All right, let's take a look at a second example here. Okay. Again, same idea. So find your max line, find your min line, and then the center. Well, there's 8 units between the max and the min, so the center line would be 4 units away from either, which is here at -3. The center line is at -3, so the value for D is at -3. Okay. The A is the distance from the center to the max or the center to the min. And so you can count here, A is 4. B is the length, B is the number of rotations from 0 to 2 pi. So if we count, here's 1 and here's 2. There's 2 rotations from 0 to 2 pi, so our B value is 2. Alternatively, you could get B by using the formula 2 pi divided by the period. The period is the length of one rotation, so from start to finish, this purple rotation takes pi units. 2 pi divided by pi, you get 2 that way for b as well. Notice that our y-intercept here is down at the bottom, and so this is going to be a negative cosine function. So if we're putting it all together, our equation is y equals a, which is 4, cosine, actually it's negative 4, cosine bx, or 2x, plus d. And that's the equation for that graph.